Right, so in this video I'm going to have a look at Euler's identity, which I've written out here. It's e to the power of pi I plus 1 is equal to 0, or you can write it as e to the power of pi I is equal to minus 1. Now, first thing I've done here is just written out the Maclaurin Series. It's f of x equal to f of 0 plus the first derivative of the function at 0 times x, second derivative of the function at 0 times x squared over 2 prime, or 2 factorial rather, and so on. Now we're going to use this. I'm not going to go through where this formula has come from. I'll do that in a different video at some stage. But I'm going to use this to write out the Maclaurin series for the cosine of x and the sine of x first of all. So let's do that. So first thing I'm going to do is let's say the cosine of x. We'll do that one first. So my function is the cosine of x. Now, in order to write out the power series or the Maclaurin series for this particular function here, I need to find f of 0, first derivative at 0, second derivative at 0, and so on. So let's do that. Well, let's say we'll do 4 of them anyway. So let's write down the first derivative of x is going to be, well, that's just going to be, cos is minus sine, so that's minus sine of x. Next derivative then is just going to be, well, the derivative of sine is cos, so this is going to be minus cos of x. The next one then, third one, is, well, cos is minus sine, so minus minus is plus, so that will give me sine of x. And we'll do one more, so this is the fourth one. Sine then will give me cosine. And we're back to here again, so it just keeps repeating then from there on in. So that will continue on. Okay, so now I've got to work out f0, f prime 0, double prime, and so on. So let's do that here. So the first one then, we need f of 0. So the cos of 0 is just 1. Let's do the next one. So the sine of 0 here is 0, so that's just going to be 0. Next one. The cos of 0 is 1, so that's going to be minus 1 here. Next one. The sine of 0 is 0, so again this is just going to be 0. And we're just starting to repeat here, so this is going to be 1 again here. Okay, so now I have a number of coefficients here that I can just stick into this equation to write out my Maclaurin series for the cosine of x. So my function, I write it in, let's say we write in blue here, so my function f of x here is cosine of x, and that's going to be, well, it's going to be 1. I'll just bring this up again here. So let's see. Yeah, f of 0 is 1. Now f prime of 0, the first derivative is 0 as well, so this becomes 0. So this term will disappear. This will be 0. Now the second one here is, the second derivative is minus 1, so this becomes minus 1, so this becomes minus x squared over 2 factorial. Minus x squared over 2 factorial. So that's my next one here. Minus x squared over 2 factorial. Next one then is the third derivative is 0, so this will all disappear here. And the next one is 4 cubed over 4 factorial, which is going to have a 1 in front of it, so there's going to be one of those, so I'll just stick that in there as well. Okay, so this is going to be plus x to the power of 4 over 4 factorial. And you can probably see the way this is going to work. The next one is going to be minus. It's going to be x to the power of 6, and we've gone 2, 4, so this is going to be 6 factorial here, and it's going to be plus, and so on. So this is my series for my polynomial, if you like, for cosine of x. Okay, so now I'm going to do sine of x. So let's work that out. Okay, so I'm going to do my function here, f of x, is equal to sine of x. So again, I've got to work through a few derivatives here. So I'm going to do first derivative, sine of x is going to be cosine of x. Second derivative, it's going to be minus sine of x. Third derivative, it's going to be minus, sine is cosine, so it's going to be minus cosine of x. I'll do another one. Cos is going to be minus sine, so this is going to be minus minus is plus, so this just simply becomes sine of x. And you know what, I'll just do one more. So this is going to be the fifth derivative, sine is going to be cos of x. And this goes on forever as well, of course. So let's just stick in our 0 values for x there. We're doing this at 0 for the Maclaurin series, so it's going to be f of 0. The sine of 0 here is going to be 0. First derivative at 0. The cos of 0 here is going to be 1. Second derivative at 0 is going to be 0 again. Next one here, the third derivative at 0 is going to be minus 1. Next one, the fourth one here, that's going to be, sine is going to be 0. And the fifth one here at 0 is the cos at 0 here is going to be 1. Okay, so I have all my coefficients again, and I'm just going to write these out. You're going to have to take my word for it now, but I'll write out the Maclaurin series for sine of x. So my function here of x is the sine of x, and its Maclaurin series is going to be well, f of 0 is 0, so the first term will just simply be 0. Second one then is 1, so that's going to be 1 times x, which is just x. Next one then is going to be minus 1. Well, actually the following one is 0, so that's going to disappear. It's the one after that. The third derivative is minus 1, so it's going to be minus x cubed over 3 factorial. The next one then is 0, so that will disappear, and the last one then is the fifth derivative, which is 1, so that's going to be plus 1 times x to the power of 5 over 5 factorial. And you can see these are all the odd numbers here. You've got 1 power of 1, power of 3, power of 5. Here you've got factorials 3, 5. So you can see the way this is going to go. The next one will be 0, but the one after that will be x to the power of 7 over 7 factorial, and then it will be plus here, and that will go on forever. Okay, so we have sine here, and you know what? I'm going to write out 2 more series underneath this because I want to use these. Now, I'll write out the cosine one again here, just quickly. So the cosine of x here was 1 minus x squared over 2 factorial plus x power of 4 over 4 factorial minus x to the power of 6 over 6 factorial plus and so on. Now if you look at these two series, they are generally related. You look as you think you could probably slot one inside the other. Here you've got odd numbers, here you've got even numbers. So maybe you could have a 1 first, then the x, then an x squared, this one here, then this one, then this one, then this one. They could combine somehow. So what I'm going to do is I'm actually going to do that. I'm going to combine them, but what I'm going to do is first of all I'm going to look at e to the power of x. E to the power of x. Now I'll do that in a different color. Now we did the power series for e to the power of x in a previous video, so I'm not going to go through that in detail. So I'm just going to write it out. E to the power of x. So another function then we're going to call e to the power of x, and its series was 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the power of 4 over 4 factorial, and so on. X to the power of 5 over 5 factorial plus x to the power of 6 over 6 factorial plus, and so on. Now you can probably see at this stage that there is a relationship between these two series here and this particular one here. We have a 1 here, we have an x here, we have an x squared over 2 factorial here, however the sign is different. Here we have an x cubed over 3 factorial, here and here, but the sign is different. Same here, here and here, and so on. Okay, so let's just have a look at putting in. What I'm going to do is take this series here, and instead of the x here I'm going to put in ix, because remember we're looking for Euler's identity, or Euler's formula initially anyway. So Euler's formula has an e to the power of ix in there, so we're going to write that in. Okay, so e to the power of ix. So wherever I have an x along here I can just stick in ix. So let's do that. We have 1 plus ix plus ix squared over 2 factorial plus ix cubed over 3 factorial plus ix, I'll do a few of these, 4 over 4 factorial plus ix power of 5 over 5 factorial, and finally I'll just do this one, ix to the power of 6 over 6 factorial. Okay, now if I do this, what I'm going to do next is I'm just going to multiply out these i's, these brackets here, see what I end up with. Okay, I'll come back to these two in a few minutes. Okay, so my e to the power of ix becomes 1 plus ix. Now, ix all squared, well, I squared will give me minus 1, so this is going to become minus x squared over 2 factorial. This one here is going to become, well, it's going to become x cubed over 3 factorial anyway. So we're going to have an x cubed over 3 factorial, but what about the I? So what's I cubed? I times I, that's minus 1. So I'm going to have a minus there, times I, so that's going to be minus I times x cubed. Okay, let's do the next one. Now, we're going to have an x to the power of 4 anyway, so we're going to have x to the power of 4 over 4 factorial. Now, what about I to the power of 4? Well, I times I, that's I squared times I squared. Well, I squared is minus 1, so minus 1 times minus 1 is plus 1, so this just becomes plus x. But this fifth one here, well, I've done 4 already, and that was plus 1, so I've got an I left over, so it's just going to be plus I times x to the power of 5 over 5 factorial. And we'll do one more then. So I have, let's see, I to the power of 6. Well, I'm going to have the x to the power of 6 anyway, and that's going to be over 6 factorial. What about I to the power of 6? Well, that's going to be I squared times I squared times I squared. Really, it's going to be, I'll just do it over here quickly. It's going to be I squared. Oops, let me just go back a bit here. It's going to be I squared cubed. 2 3's will give me 6. That's I to the power of 6. Well, we know I squared is minus 1. So minus 1 to the power of 3, that's going to be minus 1. So I'm going to have a minus here, minus in front of this x cubed. So here it's going to be minus x to the power of 6 over 6 cubed. And you know what, I'll do the next one. I'll just stick it in here. It is also minus I x to the power of 7 over 7 factorial. Okay, and this goes on forever now. Okay, so let me just get rid of this bit here. Right, now what I'm going to do next is just take the real parts, put them together, and now I'm going to take the imaginary parts and put them together, see what I end up with. Okay, so this one here is real, so I'm going to put that there. This is imaginary. This part here, minus x squared over 2 factorial. That's real. This is imaginary. This here is real, so I'm going to put that together, plus x to the power of 4 over 4 factorial. This is imaginary, this is real, so I'll put that in there, minus x to the power of 6 over 6 factorial. And that goes on forever. Okay, plus, now I'm going to take the imaginary parts. Now all the imaginary terms here have i's in them, so I'm just going to take that outside the bracket here and factorize it. So I'm left with an x here. There's an I here, so that's going to be minus, that's going to be x cubed over 3 factorial. Next one is this one here, so that's going to be plus x power of 5 over 5 factorial. Next one is going to be minus, it's going to be x power of 7 over 7 factorial, and that goes on forever. Now you've probably spotted what's happening here. If you look at this series here, let's go back up here a little bit. It has 1 minus x squared over 2, all the even powers here, even factorials. And if we look up along here, it's going to be this one here, 1 x squared over 2, 4, 6, and so on. So this one here is in fact cosine of x. Look at this one here, you probably guessed that this is sine of x. We have all the odd powers, odd factorials here. And if we look back up here at sine of x is actually, this is its power series here, cubes, odd factorials, 5 factorial, 7 factorial, powers of 3, 5, 7, and so on. So we can rewrite this as, and I'll do this slightly different color here, so e to the power of I x as, this we said was cosine of x. Over here we have an I, and we have the sine of x here. Sine of x here. This is Euler's formula, really. But what we're going to do here, and we did this in a previous video, we said let x here equal to pi. Okay, if x is equal to pi, what do we get? We get e to the power of I pi. I'll write it as pi I equal to cosine of pi plus I sine pi. That gives me e to the power of pi I equal to the cosine of pi. Well, pi is 180 degrees. It's that there, isn't it? So that's 180 degrees, or just pi out as far as there. Okay, so the cosine of pi then is going to be just simply minus 1. So the cosine of pi minus 1. Plus I times the sine of pi then is 0. So we end up with e to the power of pi I equals minus 1. Okay, so we have Euler's formula here, and we have Euler's, it's called Euler's identity here. Sometimes again, as I say, that's written as e to the power of pi I plus 1 equal to 0. Now I did this in a previous video, I did it a slightly different way. This is a kind of a longer way of getting there, but very interesting as well, I think.